So let's go through this. I won't do every single question, but most of them. So here, the first one, the chef sets an oven timer that displays 1 minute increments. Okay, that is a very important uh, piece of information there. It's telling you what it's going up by, increments, or it could say something that displays the time to the nearest minute, or with markings close to the nearest minute. That is where we get our precision from, right there. Not from this. You could have. If this had been absent, then we just go by that, right? Which would also have been to the nearest minute. But just watch out. Sometimes they differ. Uncertainty is half of that. And there it is. I would like to give you a little, just at the top here, precision. You might want to add this to your study sheet, right? If it mentions markings, that kind of trumps everything. Markings, or is marked to the nearest, or it's increasing by. It's words, right? It's a word, a statement of some sort that trumps everything. Then you have the second part would be the actual measurement. Right? You get it from the actual value that you see. And the last one is the picture. And that one I will talk about it just now, which will also be on the AC. So you will be prepared. But those are three ways we can draw our precision from. Okay? And once you get your precision, you get your uncertainty just like that, just by dividing it in half. So let's keep going. 37.8 degrees Celsius, you're focusing on that. Okay? So it's 0.1. The precision is to the nearest, right? It's by that first decimal place. And you just place a 1 in there. And half of that is 0.05 degrees Celsius. Okay? So that's where we get our precision from. Next, gold. Anybody sold gold before? Did you ever sell your jewelry? I always wanted to do that. I don't know. I have a gold necklace that I barely ever use. Buy my wife something nice with it. Yeah, all the time. Depends on the stock market. Yeah. Gold is one of those things that always appreciates as well. It drops from time to time. Anyways, so that's where this is really precise, right? The more decimals this thing has, the more precise that device is, the scale in this case. So we go 0 point count, 1, 2, 3, right? So you need to make sure that the 1 shows up on the third decimal place. Okay? And then you divide that in half. And if you're not sure, just go divide it by 2 on your calculator, because if you're off by a 0, you're wrong. Okay? So you might think it's a small mistake. Not really. Precision here. It's to the nearest meter. It's simply to the nearest meter. There is no decimal there. So it's to the nearest 1 meter. Okay, so 0.5 of a meter is your uncertainty there. So no diagrams whatsoever. Notice that. Next, there's a sprint here, 100-meter sprint, and this is the time we're given. What's the precision of the timer that they've used? You focus in on that. And so it's 0.01 of a second, right? It's 2 decimals, so make sure this has 2 decimals. Zeros everywhere except for that decimal that it comes down to. The uncertainty is half of that. So it says that. This is the one that throws some students off. Write the sprinter's time, including the measurement uncertainty. So it's basically this. Measurement plus or minus uncertainty. That's what they're asking for. Give the measurement with its uncertainty. So it would be 10.23 seconds plus or minus whatever you determine to be the uncertainty. That's what they're asking you to state there. And now, given the uncertainty, what's the maximum and minimum times it could have taken for this to take place? So max is, how do you get your max? Add them, right? Add these two together. 0.005, you add it, and to get your min, to get the fastest time that it would have taken, you go minus 0.005. So if you add it, make sure you use a calculator if you're not confident with the decimal places, because we do not round in this unit. It's that. And the lowest, if you go this minus that, is 10.225 seconds. Okay, so you get that third decimal introduced to the time. Okay, so and in between you would have that 1023. 1023, and then it can go a little higher, a little lower than that. But we're aiming for that 1023, right? So that's that for this page. The back side, I will only do 2 questions, okay? Because I gotta make sure you have enough time for that AC. It doesn't take very long. It's a shorter AC, but it will test you on all these concepts here. You good? Okay, back side. I will do question 8. 8 and 10. I will just do 8 and 10 on the back. So the rest, I posted this key actually. It's on Google Classroom. It's in yesterday's posting. So if you want to know the rest, just go check it out. Susie measures a piece of fabric to be this much, right? She cuts off. That's important. You're cutting off. That tells you that you're going to have to subtract, right? We're taking away, right? This much. So this is the piece, original, but we're cutting off this much. What is the length, including the uncertainty, of the remaining piece of fabric? Okay, so what you do here is this is how I'm going to suggest you do. 5.56 meters, put it like this, come up with the precision of it. What's the precision of this piece of fabric? Or, yeah, of this piece here. The first one is 0.01, correct? Meters. Then write the uncertainty right next to it. Half of that is 0.005 of a meter. So I just take this and I divide it in half to get that. And I'm cutting off. So I'm going to go minus 2.61 meters. Would you agree that they have the same precision? This piece has the same precision? Yes. And the uncertainty is going to be the same. It just happens to be the case. Okay. Then you do one of these. And you subtract those measurements, what you're cutting off. So 6 minus 1 is 5. I got a borrow here. Sorry. 6 minus 1. Yeah, okay. 15 minus 6, that's 9. And this turned into a 4, right? 4 minus 2 is 2. So you're left with 2.95 meters plus or minus. Forget about the precision, okay? So I kind of want you to do this now. Don't worry about that. We want the combined uncertainty, so you add these two up. You always add, okay? You always add your uncertainties together. Even though right now we're taking away here because we're cutting away from that piece, we add these up so you get 0.01 of a meter. And this is your answer for this question. This is how much is left over with the uncertainty, okay? And the reasoning is the whole piece is 5.56, and then you measured 2.61 again, right? You measured again, so there is an uncertainty there. And so the uncertainties combine, okay? Next, question 10. This is as challenging as it probably will get. So it's not too bad, you just have to be careful. So circle 10. Jack works in shipping and receiving and has 4 pieces. That's a key there, 4 pieces, right? And we're loading them, right? So there's one piece, there's the other, 3, 4. What is the total mass and the combined uncertainty, right? So there's a combination, there's a bunch of uncertainties combined. So this is how I do it. I write them in order. So 563 kgs. We're going to come up with the precision of that, which is 1 kilogram, right? And the uncertainty for that, I guess, piece is 0.5 kgs. This is going to be a little trickier, so I really encourage you to write this one down. The next piece is 69.0 kilograms. What's that 0.0 there? I will just ignore it. Nope, don't ignore it, because this piece has been weighed with a more precise instrument. So we have the precision of this is 0.1 kilograms, which means that my uncertainty is 0.05 of a kilogram. Okay. So it had 1 decimal, so my precision is now 0.1. So out of these 2 pieces, this was more precise because it's smaller, right? The units of measurements are small. Next, 1125 kgs. I think you're getting it already, so I'm just gonna assume you understand, right? This doesn't have any decimals, so we're down to the nearest kilogram. So it's just half of that for my uncertainty. And the 4th piece, watch for that one. What's the precision for that one? 0.01. 0.01 of a kilogram. That's how precise that thing is. And the uncertainty for this one is 0.005 of a kilogram. This is how I suggest you do this. And once you're done this, I almost want you to ignore this because I have students that will add the precisions together as well. We don't want that. Okay? Once you just need it once to come up with the uncertainty. And we're putting all of these pieces in one, the combined. We want to know the combined weight. So we're going to add. So we're going to add the weight and we're going to add the uncertainties. If you have a calculator, I strongly encourage you to just see how that works for you. So I'm just going to go and add everything up. And the weight is 1,767.05 kgs, plus or minus. You have to be very careful with decimals here. So if I add all of these up, I get, watch this, 1.055. 1.055 kg. So this is the combined mass of all 4 pieces with the combined uncertainty. So when you put it all in one bundle, you could be off by about a kilogram, more or less. Okay? And the more you do this, the more uncertainty there will be. So the best thing would actually be to just pile them all up and then just weigh it all at once, right? Instead of weighing them individually and then loading your trailer or whatever you're doing. Okay. It's kind of like, what do you call that game again? Is that the telephone game? You know that one where you whisper something in someone's ear? The further down the road it gets, the more off the message will be, right? So it's kind of like that with this. The uncertainty starts building the more you add individually, right? The more items are on the list, the more people there are in the circle, I guess. Okay, let's do this last one here. Oh yeah, we've got lots of time. Go to page 17, which is after 16. It doesn't have a page number, I apologize. I will start with a thermometer, so I'm kind of gonna jump all over the place here. This was an old AC, I just added it to this, so you know you're gonna get some of this stuff. And it's actually not too bad if you just follow along. So if you're given a picture, there it is. If you're given a picture of an instrument and I ask you for the precision, start with the precision every time. You gotta ask yourself, don't look at the numbers. Ask yourself, how much are you jumping from one marking to the other marking? Can you see what the pattern is? What are you going up by? You're going up by 10. Okay, and I will always make sure it's consistent. Okay, there should always be consistency. So in this case, your precision is 10 degrees Celsius. You go by the markings. In this case, every single marking is labeled, so it makes it a little bit easier. What's the uncertainty therefore? There you go. So this is where you don't always have the 1 or the 0.1. It's actually, you just got to look at what's happening there. So what would you say the temperature is according to this? So you kind of just go and see which one is this the closest to. It happens to be exactly on 20 degrees Celsius, this, right, the temperature here, plus or minus 5 degrees Celsius. We will just say it. That's just standard. You're like, no, Mr. Dirksen, I can clearly see it's 20. Standard practice is to say it could be over or under by 5 degrees Celsius. Okay. Let's go to that beaker there. Or is it a graduated cylinder? Who knows? Does it have a degree? I don't know if you know those terms, but I believe this is a graduated cylinder. I'm not 100% sure that's what you call it. What's the precision for this? Oh yeah, Mr. Dirksen, 100. I can easily see that. What are the markings? From one marking to another, yeah, you can tell that this is going up by 50 at a time, right? So it's 50, 50, 50, right? Every time you're going up, it's 50 at a time. So the markings tell me that the precision of this measuring device is to the nearest 50 mLs. And therefore my uncertainty is half of it, which is no problem, right? Half of it. This should be pretty doable, I hope at least. And some of you might think, but Mr. Dirksen, it starts at 100 and then it goes up by 50. So don't worry about it. Just go with what you have. Don't worry about this gap here. Okay. Now let's up the challenge a little bit. Let's go to this one here. Oh, fractions. I don't like this already. Okay. So the assumption is that we are talking inches here, so you can write that down. I didn't add that. What I would like you to do in this case, if you're not sure, go from 1 inch to the other, right? And then just count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 gaps there, which means that every marking represents 1/8 of an inch. And if you don't like fractions at that point, you just go 1 divided by 8. So you can also say it's to the nearest 0.125 of an inch. So either way, if you like fractions, stay with fractions. If you like decimals, go with decimals. But you kind of have to count. If there had been 16 gaps, then it's 1/16. That's the precision. Okay. What's the uncertainty? What's half of 1/8? It's 1/16. It's 1/16. Think of a pizza. If there's 8 slices, if you want to cut all those slices in half, you'd now have 16, right? So it's 1/16 of an inch. Or look at this. If you figured this part out, the 0.25, you could just divide that in half and just get your uncertainty that way. So this one, if you scratch your head a little bit, you will get from time to time an imperial measurement. That's just, I can't help it. You need to know how to do it. What would be the measurement of this line, including its uncertainty? Well, if you measure from this front to this, it's closest to this line. So half an inch would be 4/8, right? 1, 2, 3, 4/8, 5/8. So this is the 5/8 mark right here, and it's closest to it. So we would have to say 5/8 of an inch plus or minus, and here's where you decide. Do you want to state the decimal or do you want to state the fraction uncertainty? It's up to you. I wouldn't take marks off because both are correct. Both are correct. And it's gonna be imperial, guys. So it's not like I'm throwing like something else at you there. Yeah. Oh, no, it wouldn't be. You almost got me there, but that line starts at 5, right? And it's just from there, so it's still not quite right. So if it had been a ruler, right, where it goes all along from 0 all the way past 5, then yes. Yeah, so watch out for that. Yeah. One last one. And then, what about, you know what this is called? It's a caliper, vernier caliper. Okay, so it's just to measure the diameter of things. So what would be the precision if you had to look at this? What would it be? You're like, it's a picture, but it gives me the actual digital measurement. So you got to go by that, right? So this would be 0.0. Whoa, what's happening there? It's blurry. This is what some of you are gonna see on after graduating, right? Anyways, 0.01, right? 0.01 of a millimeter. And then half of that would be 0.005 of a millimeter. I'm just splitting that in half. So the measurement with its uncertainty would be 17.20. For us in this unit, it makes a big difference whether you say 17.2 or 0.20, because the precision of the device is in question here. All right, that's that. And the metric ruler or measuring tape, you should be just fine with that. What's the precision of this device? You should be able to answer it without even thinking much. Okay, so you're staying with centimeters. So I will apply the same rule here. Let's start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/10 of a centimeter, which is 0.1 of a centimeter, correct? Could you say millimeters? 1 millimeter? 1 centimeter has 10 millimeters, right? So these are actually millimeters as well. So you can do that if you want. You can do that if you want. I'm going to go 1 millimeter. They're all the same thing. So half of that is 0.05 of a centimeter, or 0.5 of a millimeter. Like if I'm splitting this in half, right? Or if I split that in half. There you go. What's the measurement of this thing? So you gotta kind of see which one is it closest to. It's actually closest to 18, I think. So it'd be 1.8 centimeters plus or minus 0.05 of a centimeter. And again, I won't be too picky if you're off by a little bit, as long as it matches close enough. All right. So just close your books, or you can leave it on your desks, or you can pack it if you want.